Hi students, hope you all doing well. This is Parthiban, postgraduate maths teacher. I welcome you all to Vidyalakshmi YouTube channel. Today we are going to see very important topic, that applications of integral calculus. Before entering into the topic, let us recall the things that you could have studied in 11th standard. Let's go straight away. Point number 1 is here. First, let us understand what is meant by integration. Integration is nothing but antiderivative. That is, in 11th standard, in chapter 10, you could have studied a derivative. The process against the derivative is called integration. So, here you can see the picture. See, this is the given function y. From that, we are getting dy by dx. This process is called differentiation. You know it well. The process, reverse process, that is getting y from dy by dx is known as integration. And usually integral of the function f of x with respect to x is represented by capital F of x plus c. Okay, now let us go to the next topic, next page. So by using the antiderivative concept, these are the important formulas you could have studied in 11th standard. Please recall, without these formulae, it is very hard to go for 12th concept. Please recall all these formulae. Once again, you see that the integral of the constant k is nothing but kx plus c. Then integral of the function ax plus b whole power n is 1 by ax plus b whole power n plus 1 by n plus 1. So like that, you got the integral for 1 by ax plus b e power ax. The integral of e power ax is e power ax by a plus c. Like that, all these things you could have studied in 11th standard, but just have a recall. Sine, integral of sine of ax plus b is minus cos of ax plus b divided by a. In the similar way, you are getting tan of ax plus b. The integral of tan of ax plus b is 1 by a log of modulus secant of ax plus b. Just have a glance. Next set of formulae. Here you see that the integral of cot of ax plus b is given by 1 by a log of modulus sine of ax plus b. Like that, you see all the formulae one by one. Just for recall purpose, I have given this. And finally, you are getting 1 by x square minus a squared. The integral of 1 by x square minus a square is given by 1 by 2a log of modulus x minus a by x plus a. Then finally, you are getting this set of formulae. Integral of 1 by root of a square plus x square is given by log of modulus x plus root of x square plus a square. In similar way, integral of 1 by square root of a square minus x square is given by sine inverse of x by a plus c. Like that, you see all the results one by one. Just recall all these things you studied in 11th standard. Just have a recall. Next, let us go to the next page. And fourth point is that linear property. Linear property of integration. Linear property of integration is nothing but integral alpha f of x plus beta g of x is given by alpha integral f of x dx plus beta integral g of x into dx. That is, we can take out the constant outside of integration. Either it is plus or minus, you can integrate them separately. That is the thing they are telling us through linear property. Next, types of integrals. It is very important. There are two major classifications on integration. First type is that indefinite integral. Indefinite integral, which is represented by integral f of x dx. Whereas definite integral is represented by integral a to b f of x into dx, where a is the lower limit, b is the upper limit. Let's go for a small discussion that why the first integral is called indefinite integral and the second integral is called indefinite integral. Just a small rough work here. Let's go for a small rough work. Simply let us take the function f of x equal let us take the function f of x equal to x. f of x equal to x. Let us find out indefinite integral for this. So integral f of x into dx, which is nothing but integral, what is f of x here? X into dx. What is the integral of x? See here, x means x to the power of 1. We know the formula for x power n. Integral x power n into dx is nothing but x power n plus 1 by n plus 1 plus c. Make use of that formula here. You are getting that x power n plus 1. What is n here? 1. 1 plus 1? 2. 2 by 2 plus c. That's it. So the integral of x is x square by 2 plus c. In the similar way, let us compute the definite integral for the same function. Okay, integral f of x into dx. For an example, let us consider the limits 0 to 1. Lower limit to be 0, upper limit to be 1. Any limit you can take. Here for convenience, for simplicity, I take lower limit to be 0, upper limit to be 1. And this is nothing but integral 0 to 1. What is f of x here? X into dx, which is nothing but, what is integral of x? X square by 2, as we done in the previous case, x square by 2. Then you have to put up lower limit and upper limit. Lower limit 0, upper limit 1. So while evaluating the integral, always you have to substitute upper limit first. What is upper limit here? 1. 1 is the upper limit. So replace x by 1. Here if you take 1, 1 square 1. Okay, 1 square by 2 minus, then take lower limit. What is lower limit? 0. 0 square is 0. 0 by anything 0. So finally you are getting that 1 by 2. You are getting 1 by 2 as the output. You see both the outputs. This is the output we are getting when we deal with indefinite integral. Whereas you are getting the output 1 by 2 when we deal with definite integral. Why it is definite? Definite means particular, precise, fixed. See 1 by 2. 1 by 2 means 0.5. It won't change. It is a constant, fixed. So that is why whenever you are getting limits, lower limit, upper limit, that integral is said to be definite integral. Definite means particular, fixed. Whereas the integral without the limits is called indefinite integral. Indefinite means it is not precise, it is not particular, it is not fixed. You see that in the answer x is involved, where x is the variable. As x varies, answer of this function will also be changing. If you give x equal to 1 here, answer will become 1 by 2. If you give x equal to 2 here, 4 by 2, 2 plus c will come up. If you give 3 here, 3 square 9, 9 by 2 will come up. So here it is changeable. It is not fixed. It is not a constant. That is why this is said to be indefinite integral. Second one is said to be definite integral. Keep it very simple. The indefinite integral means output would be a function of x. Whereas in definite integral, output would be a constant. So keep it very simple. Okay. Now let's move on to the next page. And this is the pure 12th syllabus. See, previously in 6 pages we have recalled the things that you studied in 11th standard. What is meant by integration? What are the things we have seen so far? Have a look at them. First one, what is meant by antiderivative? How we can represent antiderivative? Then important integral formulae collection. Student, these formulas are very, very important. Without these things, you cannot step into integral chapter. So please be thorough with them. Linear property of integral. Next, 2 major classifications of integrals. Then pure 12th syllabus. Students, in 12th, we are mainly going to focus on definite integrals only actually. Limit integrals only. You forget about indefinite integrals. Hereafter, we are going to focus on definite integrals only. Okay. This is pure 12th topic. The topic is that evaluation of definite integrals. Method 1, Riemann sum method. See, when you go to Riemann sum, there are 3 subdivisions. Number 1, left hand rule for Riemann sum. Left hand rule. Left hand rule for Riemann sum, and it is given to be integral a to b f of x dx equal to f of x naught, actually this is f of x1 plus etc f of xn minus 1 into delta x. And second Riemann sum is for right hand rule. Riemann sum for right hand rule. it is given to be integral a to b f of x dx equal to f of x1 plus f of x2 etc f of xn into delta x. And finally, third one, midpoint rule for Riemann integral, it is defined to be integral a to b f of x dx equals f of x0 plus x1 by 2 plus f of x1 plus x2 by 2 etc f of xn minus 1 plus xn by 2 into delta x. Students, you might be under some confusion that what is meant by x0, sir, what is meant by x1, what is meant by delta x. For this, let us go for a small rough work. Okay, students, let us consider the piece of real line like this. Okay, let us consider the piece of real line like this. Let us assume that this point is A and the ending point is B. See, in our given integral, it has been given that integral starts with A and ends with B. So, A to B. Okay. Next, let us divide this interval into n subintervals like this. Here I take the point x1. Then I take the point x2 here. Then x3 here. And proceed. So on. Here you are getting x suffix n minus 1. And this is our xn. Initial point is x0. Final point is xn. The intermediate points are x1, x2, x3, etc. xn minus 1. Students, dividing the piece of a real line like this small intervals is known as partition. Dividing the piece of the real line like the small intervals a to x1, x1 to x2, x2 to x3, etc. xn minus 1 to b. Such an arrangement is called what? Partition. Partition of the interval. It is called what? Partition. Partition of the closed interval a comma b. Students, here we need to assume one more thing. Here you can find out the width of each interval. What is the width of this first interval? x1 minus x0. What is the width of the second interval? x2 minus x1. In the similar way, what is the width of the third interval? x3 minus x2. And so on. Finally, you are getting the difference as xn minus 1. So these are the widths of each interval and we need to assume them all equal here. Let us assume that all intervals having equal width and say it is delta x. Students, you may ask, sir, if the width of the intervals are different, what will happen? Of course, we got the formula for that, but that is beyond the scope of our textbook. We are going to deal with the intervals with equal widths only. Okay, you assume like that. Okay, again we can have a look at the formulas here. Students, you have to be little care here. Left hand rule. Left hand rule means we need to start with left hand, x0. You see that real line here? What is the left hand? You see that what is our left hand? x0. So whenever you deal with left hand rule, start with x0 and x1, x2, etc. You should not take right hand. That is very, very important. Left hand rule means start with left hand, ignore right hand. When we deal with right hand rule means include right hand, that is xn, ignore left hand x0. You see the formula given over here? Left hand means we are starting with x0. We are ignoring xn. When we deal with right hand rule, we are including right hand xn, but we are ignoring x0. Whereas in the midpoint rule, we should take all points into the count. You see that x0, x1 coming into play, x1 and x2 coming into play, etc. xn minus 1, xn coming into play. All points are coming in midpoint rule, where you are taking the average x0 plus x1 by 2, x1 plus x2 by 2, etc. xn minus 1 plus xn by 2, like that. So you have to take little care. Left hand means start with left hand, ignore right hand. Right hand means take right hand, ignore left hand. Midpoint rule means take all points into the problem, into the count. I hope you understand this. Let's go to exercise 9.1 straight away. There are 3 sums. Each problem is a 3-mark question. Students, listen carefully. Easily you can get 3 mark. Let's have a look at question number 1 here. Find an approximate value of integral 1 to 1.5 x dx by applying left hand rule. That is very, very important. Though you got 3 rules there, we have to utilize here left hand rule with the partition 1, 1.1, 1.2, etc. 1.5. Partition is given straight away. Okay, students, here we are going to utilize left hand rule. Okay, let's enter into the problem. First, let us gather given informations from the given integral. What is the lower limit? 1, which is a. What is a value here? 1. Upper limit, we should take it to be b. What is b? 1.5. Next, f of x. That is a function needs to be integrated. What is our f of x here? X. X. Okay. Next, let us have a piece of real line. We need to start with 1. We need to start with 1. End with what? 1.5. Okay. And what are the elements in the partition? You see the partition. First entry is 1. 1 is here you can take. This is 1. Next 1.1. Here you can take it. 1.1. Next element 1.2. 1.2. Next one 1.3. Next one 1.4. And finally you are getting 1.5. This is the partition of the closed interval 1 to 1.5. Students, here you can see that the width of each interval is what? 0.1. Subtract pani paranga. 1.1 minus 1, 0.1. 1.2 minus 1.1, 0.1. 1.3 minus 1.2, 0.1. 1.4 minus 1.3, 0.1. 1.5 minus 1.4, 0.1. So it is quite obvious that all of the intervals having same width. That thing must be taken to be delta x. What is delta x? 0.1. Students, we have collected all the required informations to enter into the problem. Let's use left hand rule here. So therefore, by Riemann's left hand rule, we have that. What we have? Integral a to b f of x into dx, which is nothing but, students, as I told you already, left hand rule means we need to start with the left hand. So moreover here, left hand must be taken to be x naught. What is this? X naught. This is our x1. This is our x2. This is our x3. This is our x4. Finally you are getting x5. So left hand means we need to start with the left hand. What is left hand point? X naught. So f of x naught. Then plus f of x1. After that f of x2. Then f of x3. Then f of x4. Students, you should not take x5 there. Left hand means you should start with left hand. Right hand should not be taken. So don't take x5 there. Close it up. Finally, you should take delta x. Okay. Now let us substitute for all a, b, f of x, x naught, x1, everything. Let's go to the next page. So integral lower limit 1, upper limit 1.5. Here our f of x is x. F of x is given to be x into dx. Open up the bracket. Okay. What is x naught value here? 1. So f of 1. F of 1 plus what is next value given there? 1.1. What is next value given there? 1.2. The next value is that f of 1.3. Next value f of 1.4. Actually 1.5 is the ending value, that should not be taken. So close it into delta x. What is delta x here? 0.1, width of each class interval. Students, in our question it has been given that f of x is equal to x. F of x is equal to what? X, which means it is an identity function. Whatever the input you give for x, the same output will come up. 1 means output 1, 2 means output 2. So in that case, f of 1, if you give 1 here means what you are getting? 1 itself. In the similar way, if you give 1.1 means what you are getting there? 1.1. Like that you proceed, you are getting the same quantity as you are giving the input. So f of 1 means what? 1. F of 1.1 means 1.1. F of 1.2 means 1.2, 1.3, and finally 1.4 into 0.1. Now let us add these quantities. First let us add decimal parts. 4 plus 3, 7, 7 plus 2, 9, 9 plus 1, 10, 10, 0, balance 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5, 5 plus 1, 6, 6.0, that is 6. So 6 into 0.1. What is 6 into 0.1? 0.6. So eventually you are getting 0.6 when we use left hand rule for the given function. And this concludes the problem. Let's have a recap. Students, see it. It is a given problem. We need to choose A, B, f of x and draw the picture like this. Plot the partition elements. Then allot what is x0, x1, x2, etc., etc., xn. Then carefully write left hand rule. Left hand should be taken, right hand should be ignored. Then substitute the values. Just simplify. Simple simplification give us the answer 0.6. Now let's move on to sum number 2. Exercise 9.1. Sum number 2. Have a look at the question. Find an approximate value of integral 1 to 1.5 x square into dx by applying the right hand rule. What is the rule you have to use here? Right hand rule. And partition is given to be 1, 1.1, 1.2, etc., 1.5. Now let us proceed as in the previous problem. The only change, actually two changes we are getting here. One thing, right hand rule. Another one, in the previous problem we got x. Here you are getting x square. Okay, let's go to the problem. Solution. So as we did in the previous problem, we need to collect what is A, what is B, what is f of x, what is delta x. Let us gather them one by one. What is A here? A means lower limit of the given integral. What is A here? 1. Upper limit B, what is it? 1.5. Next, f of x. What is our f of x here? X squared. So f of x is equal to x squared. Then we have to take delta x. For that we need to go for the real line. Let us take the real line. Piece of real line like this. So partition start with what? 1. It starts with 1. Ending with 1.5. What are the elements given in the set there? 1.1. Roughly you can plot 1.1 here. Then 1.2. After that 1.3. And finally 1.4. Students, here also you can see that each interval is of same width. 0.1, 0.1, 0.1. You see it. You take the difference. All the intervals having the same width, 0.1. So that thing must be taken to be delta x 0.1. Okay, all things are well set to go for the problem. Right hand rule. Here you should what? Right hand rule. What is Riemann's right hand rule? Riemann's right hand rule. Right hand rule tell us that, what is the rule? Integral a to b f of x dx is nothing but, students, again I tell you, right hand rule means right hand must be included, whereas left hand should be excluded. So that is very, very important. Moreover, here we can name the entries. First entry x0, second entry x1, and this is x2, this one is x3, this one is x4, finally you are getting x5. So we need to start with x1. So f of x1 plus f of x2 plus f of x3 plus f of x4, finally you are getting f of x5. And don't forget to take delta x finally. Now next step is a purely substitution. Substitute for a, b, f of x, purely substitution. Let's go to the next page. So integral 1 to 1.5. What is our f of x here? X square into dx, which is nothing but f of, what is the first value we need to start with? X1. What is x1? 1.1. Till 1.5 you should go. So f of 1.1 plus f of 1.2 plus f of 1.3 plus f of 1.4, finally f of 1.5 into what is our delta x? 0.1. And here it is given that f of x is equal to x squared. See, whatever input you give, square will come out. 1 means 1 squared, 2 means 2 squared, 3 means 3 squared. Like that you proceed. What is the answer for f of 1.1? 1.1 whole square. So 1.1 whole square. The output for f of 1.2 is 1.2 whole square. And this is 1.3 whole square. This one is 1.4 whole square. At last you are getting 1.5 whole square into 0.1. And this is nothing but, what is 11 into 11? 121. 11 11s are 121. 2 decimal points will be coming. So 1.21. 12 12s are 144, which means 1.44. 13 13s are 169. 1.69 will come up. 14 14s are 196. 1.96 will come out. And finally 15 15s are 225, which is 2.25 into 0.1. Now students, who carefully add all these decimals. You should add carefully. Okay, first let us go to the last digit. 5 plus 6, 11. 11 plus 9, 20. And 24, 25. 25, 5 will come up. 2 is the balance. 2 plus 2, 4. 4 plus 9, 13. 13 plus 6, 19. 19 plus 4, 23. 23 plus 2, 25. 25, 5 should come up. Again 2 balance. 2 plus 2, 4. 4 plus 1, 5. 5 plus 1, 6. 6 plus 1, 7. 7 plus 1, 8. So you are getting the total to be 8.55 into 0.1. And you should multiply this quantity by 0.1. You are getting that. You simply take 1. 1 into 855. 855 will come up. Totally how many digits are there? 1 digit. Here 2 digit. Totally 3 digits will come into play. So 1, 2, 3. So point should come up here. So eventually answer is 0.855. And this completes the problem. Students, it is very easy that you can get 3 mark. So get A, get B, get f of x. Draw the rough diagram like this. Write the formula. As soon as you write the formula, the very next step is nothing but pure substitution. Just simply substitution, simple calculation giving us the answer. Students, I hope you understand this problem. Now it's the time to go to sum number 3. Have a look at this. Find an approximate value of integral 1 to 1.5, 2 minus 2x. Student, you see that you got change of function over there. 2 minus x into dx by applying what rule? Midpoint rule. You see it. In the first problem you applied left hand rule. In the second one right hand rule. But in the last one we are utilizing midpoint rule. The partition remaining the same. So as usual, let us proceed. Solution. Students, what is a here? Lower limit is a. What is a? 1. B, what is b? Upper limit. Our upper limit is 1.5. What is f of x here? F of x is equal to 2 minus x. Next we should choose delta x. For that, let us draw the piece of real line as we did in the previous problem. So like this. So partition start with element 1, starting with 1, ending with 1.5. So just mark out the entries of the partition. First entry 1.1, next one 1.2, and next one 1.3, and finally you are getting 1.4. So first value is what? x0. This is x1. This is x2. This is x3. And this one is x4. Finally x5. And it is quite obvious that here also all the intervals having same width. It is nothing but 0.1 here. So what is our delta x? 0.1. Now we have to write midpoint rule. Students, midpoint rule means no point should be left out. Left hand or right hand, all points should be taken into the account. So let us write carefully midpoint rule. Therefore, Riemann's midpoint rule is nothing but integral a to b f of x into dx equals, open up the bracket, f of, take the first two values, x0 plus x1 by 2 plus f of next two values, x1 plus x2 by 2, then plus f of x2 plus x3 by 3. Next one, f of x3 plus x4 by 2. And finally you are getting that integral f of x4 plus x5 by 2, close it up, and finally you should take delta x. So x0, x1, x1, x2, x2, x3, x3, x4, x4, x5. Next we need to substitute all values. Let's go for that. So integral 1 to 1.5, sorry, lower limit is 1, 1 to 1.5. What is our f of x here? 2 minus x into dx, which is equal to f of x0. What is our x0? 1 plus x1. What is x1? 1.1 by 2. Next, plus f of 1.1 plus 1.2 by 2. What is the next term? Plus f of 1.2 plus 1.3 by 2. And next one, f of 1.3 plus 1.4 by 2. And next one, f of 1.1 plus 1.5. 1.4 plus 1.5 divided by 2, close it, into delta x is 0.1. And this is nothing but f of, add these two numbers, 1 plus 1.1, 2.1 by 2, plus f of, if you add these two, you are getting 2.3 by 2. Next, f of 2.5 by 2. And next one is that f of 2.7 by 2. And finally you are getting f of 2.9 by 2, close it up, into 0.1. Now students, we need to utilize the given function. What is the given function? F of x. F of x is equal to 2 minus x. How it acts actually? 2 minus x. Whatever you give the input, that quantity should be subtracted from 2. If you give 1, 2 minus 1. If you give 2, 2 minus 2. If you give 3, 2 minus 3. So 2 is fixed there. Whatever input you give, that should be subtracted from 2. So make use of that idea here. This is x. This is x. So what is the answer? What is our x there? 2.1 by 2. So 2 minus 2.1 by 2 plus, what is our x here? 2.3 by 2. So 2 minus 2.3 by 2 plus, there 2 minus 2.5 by 2. And next one, 2 minus 2.7 by 2. And final term is that 2 minus 2.9 by 2, close the bracket, into 0.1. Students, you add all the 2's separately. There you can see many 2's there. Add all the 2's. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. So 10. Then you take the fractions. You see all the fractions having by 2. Denominator is common and minus is common. Take minus 1 by 2 outside. Take minus 1 by 2 outside. Add all the decimals. What you are getting there? 2.1 plus 2.3 plus 2.5 plus 2.7 plus 2.9. Close it up. Close the entire bracket. 0.1. And this is nothing but 10 minus 1 by 2 into, so as usual let us add decimal parts first. 9. 9 plus 7, 16. 16 plus 5, 21. 21 plus 3, 24. 24 plus 1, 25. 5. Balance 2. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. 8 plus 2, 10. 10 plus 2, 12. So you are getting that 12.5. Close it up. Into 0.1. Into 0.1. Here you can make cancellation. Go for a cancellation here. See, 2 6 are 12. Point. 2 2s are 4. You are getting balance 1. Take 1 0 there. 2 5s are 10. Again I repeat, 2 6 are 12. 2 2s are 4. Balance 1. 2 5s are 10. So what you are getting there? 10 minus 6.25. Here you can go. What you are getting there? 10 minus 6.25 into 0.1. What is 10 minus 6.25? 3.75. 3.75 into 0.1. So if you multiply by 1, you are getting 375. Totally how many decimal places are there? 2 plus 1, 3. So 3 digits you have to move forward. Point will come up here. So eventually answer is 0.375. Students, first 2 sums we had a less number of steps, but here in the third step, midpoint rule, we are getting somewhat lengthy steps and more number of steps too. Because of the term x0 plus x1 by 2 average, we are taking average for all the terms. So students, I hope you understand all the 3 sums. In case if this question comes for examination, easily you can get 3 mark. And with this problem, exercise 9.1 over. I hope you all enjoyed this session well. So students, please work out the problems. Don't just go through the problems. Take out a notebook. Step by step you work out. Then only you come to know where you are committing the mistake. So don't go through. Please work out. In case if there is any doubt, in the next video I will clarify them. Okay students, thank you all. I will meet you in the next class with the exercise number 9.2. Thank you.